about for the past week? What have we been talking about? Or what three forms are they talking about here? Juan, put that away, please. What are we talking about? What have we been talking about? Did the gummy bears, the catapults. You did the Desmos activity. Quadratics, yes. What about quadratics? What do they look like? Parabolas, a parabola, like an arch, a right side up or upside down arch, okay? We also talked about three different forms. Do you remember the name of the forms of the quadratic equations? You can look back in your notes. What? Factored form. Factored form is good when you are given the roots because it's a times quantity x minus r sub 1, x minus r sub 2. What else? Vertex form. You'll never guess what vertex form gives you. The vertex, yes. And standard form has coefficients a, b, and your constant c. And your constant c is going to be your y-intercept, okay? All right, so let's take a look on page 75. Follow along while I read, please. Floyd. Oftentimes, the standard form of the quadratic is used in projectile motion, meaning if you're throwing something or something is being projected out. For this particular situation, the equation height in terms of time is equal to negative 1/2 g times time squared plus initial velocity times t plus the initial height. That equation gives the height of an object at time t for an object that has an initial velocity v sub naught and an initial height of h sub naught. G is a gravitational constant and it is either 9.8 meters per second squared or 32 feet per second squared. Oftentimes, a simpler form of the equations look like this. Now, in your books, it is incorrect for meters. So I need you to put over here, this should be negative 4.9 t squared. I think you have, what do you have written in? 9.8 or something? Yeah, so take out 9.8.
Are you meaning to have this up here on the board?
No, I am not. I am not. I hate it when it does that. And I should always check. And doesn't look like I am totally connected. Let's see. Nope. For some reason, it keeps kicking me off, which is annoying. Okay. Oh, of course, now it's showing. There we go. So for the meters, it should be negative 4.9 t squared plus v sub naught t, which is initial velocity times the time, plus h sub naught, your initial height. And for feet, it will be negative 16 t squared plus v sub naught t plus h squared. All right, so it says, number one, a piece of paper and a hammer are dropped off the top of your school building, which is 90 feet high. They are both dropped from a still position. That means the initial velocity is 0 for both. If we ignore air resistance, which object, the paper or the hammer, is going to hit the ground first? It says, provide a mathematical argument that starts by sketching a picture of the graph and concludes with an analysis of the equation. Okay, first of all, if we are 90 feet in the air, which equation are we going to use? The first or the second one? What was that? The first or the second one? Yes, because we're talking about feet, 90 feet. So we're going to use the second equation, which is h of t, the height in terms of time, is equal to negative 16 t squared plus initial velocity times t plus the height, or the initial height. Okay. Then it says, provide a mathematical argument that starts by sketching a picture of the graph. All right, so we got to do a graph. Do your coordinate plane. And what do we know about its height? 90 feet high. What is that going to be for this parabola? What do we call that? Yeah, it's the vertex. It is the high point. So I'm going to go up by 20s here. And I'm going to say that right here is my vertex. That is the high point. And that vertex is 0, 90. And we're going to drop it so I know it's coming down. Okay, so the other part would be over here, but that's not really relevant to us. Okay, so we've sketched a picture of the graph and concludes with an analysis of the equation. All right, so this is my equation, and I'm talking about a hammer and a piece of paper. Talk to me about what it says we need to keep in mind for both of them. Or what's relevant in this problem? What's relevant in this problem? A little bit louder, I can't hear you. Still position, is that what you said? Yeah. Still position. Okay, so still position means their initial velocity is 0. If the initial velocity, which is v sub naught, is 0, what's that going to do to this term? Yeah, it's going to make it 0. It's going to make it irrelevant, basically. So that's a 0. Okay. What else is relevant in this problem? Girls, come on, let's put your phones away, please. What else is relevant to this problem? Do I know my initial height? 90. Is that the same for the hammer and for the piece of paper? Yes. So the initial height would be the same for both. Okay, so that's plus 90. Plus, so the height in terms of time is equal to negative 16 t squared. So we already know, since the initial velocity is 0, that that middle term is gone. We know the height. Talk to me about what's left. So if I talked about the height, let's say the height of the hammer after 1 second. What's that height going to be? The height of the hammer after 1 second. What is the height of my hammer after 1 second? What would I do to find that out? Yeah, you substitute 1 second in for t. 1 squared is 1. Negative 16 plus 0 plus 90 is going to give me a height of 74. Is that right? 74 feet? Okay, what is the height of my paper after 1 second? What's it going to be? Height of my paper after 1 second. Hello? Anyone? After 1 second, substitute 1 back in here. What are we going to get? 74 feet. What? After 1 second, they're both at the same height? What is the height of the hammer after 2 seconds? Hammer time. After 2 seconds. Anyone? Anyone? 2 squared is 4. 4 times negative 16 is negative 64. Negative 64 plus 90 is what? 26? So that would be 26 feet. What is the height of my paper after 2 seconds? What is it? 26 feet. So using this equation, which we are ignoring air resistance, the question says, which is going to hit the ground first? If our initial velocity is 0 and our height that they both start at is 90, the only variable we have to talk about is time. And time for both of them is always going to be the same, right? I mean, 1 second for a hammer is the same as 1 second for a piece of paper falling, not following. So what do you think the answer here is? Which is going to hit the ground first, the paper or the hammer? Based on this equation. Yeah, they will hit the ground at the same time. Now remember, this is given that we are ignoring air resistance, because if you take a piece of paper and you throw it up in the air, it's going to have a lot more air resistance than that hammer. But looking at this equation, the only thing we have left here that's different, or the only variable, is time. And the time, like I said, would be the same for both. So while it seems wildly inaccurate, it really is not if we ignore air resistance. Any questions about that? All right, let's take a look at the problem at the bottom of page 75. A potato, a spud, is fired from a spud gun at a height of 3 meters and an initial velocity of 25 meters per second. Write the equation of this potato projectile. How high does the potato reach? All right, so this is in terms of meters. As I look back, our meters equation was h of t equals negative 4.9 t squared. So h, height in terms of time, is negative 4.9 t squared plus, what was it? V sub naught t plus initial height. All right, where does this 3 meters go? Come on, people. I need thinkers. I don't need warm bodies. Come on, think, think, think. Where's my 3 meters going to go in this equation? For your height. And that's h sub 0, your initial height. So that is 3. right there. And it has an initial velocity of 25 meters per second. So let's put 25 over here for v sub naught. 25 meters per second. Write the equation of this potato projectile. So h of t equals negative 4.9 t squared plus 25t plus 3. Then it says, how high does the potato reach, and at what time does this occur? How high does the potato reach, and at what time does this occur? How would we start to figure that out? What could I do? Yeah, we could substitute in times, and that's going to give me the different heights along the way, right? So what's my x value, or what's my t value? Which is the x value, height or time? Does time determine the height, or does height determine the time? Time determines height. So time is going to be your x value, and your y value is height. All right, so what time would you like to start with? Well, let's just do an easy one. What if I put t, or my x is 0? So we haven't started at all yet. What is the height of my projectile? What is it, Sarah? Substitute 0 in for t. So that's going to 0 out the first term. That's going to 0 out the second term. What are you left with? 3. Why does this work? Because remember, in ax squared plus bx plus c, this c value is your y-intercept. Just like this is your y-intercept. So you need to remember that. When something is written in standard form, and that's essentially what this is, standard form, okay, the c value is the y-intercept. All right, what other value do you want to try? What time? Talon, give me a time. T equals what? Okay, let's try 4. So everybody, remember, following order of operations, you have to square that time first. Oh, that does not work. Oh, and I must have given that out. So 4 squared times negative 4.9. I gotta find my calculator. So 16 times negative 4.9 is negative 78.4, and 4 times 100 is 100, plus 3. What'd you guys get for an answer? Guys, come on. I just need you to try to put these in. You're going to have to do these for your own test. You might as well practice. What'd you get for the height? 24.6? Yes. Okay. What else? Should we go higher? Should we go lower? What do you want to try? Jill, what do you want to do? Give me a time. 8, okay. So let's put 8 squared is 64 times negative 4.9 That's negative 3, 13.6, and 8 times 25 is 200. I'm still at negative 113.6 plus 3. I got negative 110.6. So where is my spud? It is now underground. So that's too far. What are we trying to figure out here? What are we trying to figure out here? How high does the potato reach? How high? So I think we need to go maybe someplace between 4 or 8, maybe someplace between 0 and 4. I don't know. What should we try next? All right, let's try 6. The middle muddle. 6 squared is 36 times negative 4.9 is negative 176.4. 6 times 25 is 150. That's negative 26.4 plus 3, negative 23.4. So we're still down in the negative. Thank you. So I think we need to go fewer than 4 seconds. Do I have a volunteer to look at 2 seconds and a volunteer to look at 3? Jennifer, which one do you want to look at? Okay, Jennifer's going to do 2. Lonnie, you're going to do 3? Okay, somebody do 1 also, just for kicks. 4 times negative 1.9. Okay, did we get 2? What'd you get? 33.4 for 2 seconds. Lonnie, did you get 3? Or not yet? What is it? 23.9. 33.9. And at 4, we were at 26. So I would say, how high does the potato reach? At what time does this occur? Meters per second. Based on what we have here, I would say that 3 seconds is our high. Now, that is at 3 whole seconds. How do you think we could actually figure out if this is not the actual height, the high? How could we figure out what was the high? This is standard form. We also have roots. Do we have any roots here? We do not yet, do we? No. So factored form would not be good. Do we have a vertex? We don't know that we do. So I think we're going to go with that for now. So the high would be 33.9 meters at 3 seconds. And I'll have to think about that because obviously they wouldn't have to be going by whole numbers. Any questions based on the information we have for this one, though? Okay, let's go to the next one. This time we're on page 78. Excuse me. Page 78. Says the points used to model a parabola are negative 3, 0, 6, 0, and 4, negative 5. Write an equation for this parabola. Which form is most helpful and why? All right, look at these points. Negative 3, 0, 6, 0, and 4, negative 5. What do you notice about them? What do you notice? What do you observe? That's what you should be doing all the time when it comes to math. Who could I talk to? Yeah. Are you paying attention here? What do you notice about the first 2 points? Okay, one's negative, one's positive. What else? Say it one more time. They have 0. So what does that mean? You said it? I think you started to say it before. They are on the x-axis. Those first 2 points are on the x-axis. What is going on with my voice? Sorry. I know, right? So what does that mean? If these are on the x-axis, what do we call these points? The x-intercepts. What's another name for x-intercepts? I think somebody said it. Roots. Yes, and do we have a form that has the roots in it? Factored form. So probably factored form would be the most helpful. Factored form looks like y equals a times x minus your first root times x minus your second root. Wow. Write an equation for this parabola. Okay, so we have our 2 roots. Our roots are -3 and 6. But when you substitute those in, it becomes x minus -3. So this first one is going to be +3 because you can't subtract a negative. And the second one is going to become -6. Okay. We also have another point. 4, -5. We don't know what point that is exactly. But how could that help me in creating this equation? Can that help me? Say it again. Yeah, we can use 4 and -5 as our x and y values, right? This is a point on the parabola. You need to remember that. So if x is 4, substitute 4 in place of x. Okay? Like so. And if y is -5, substitute that in for y. So now we can solve for a to see what that coefficient is. And do a little math calculation and say -5 is equal to a times 4 plus 3 is 7. 4 minus 6, -2. -5 is equal to 7 times -2 is -14a. Divide by -14, divide by -14. A is equal to negative divided by negative 5/14. So writing the equation, I would say y equals 5/14 x plus 3 times x minus 6. Because usually when you write it in its form, you leave the x and y open, just to be regular x and y. So use what they give you in the problem. They gave you the roots, use the roots. They gave you another point to use for x and y. Find a and then substitute that in. Very important right there. Make sure you put an asterisk on this problem. Okay? Yeah, watch my time. All right, let's go to the next one. Does anybody need this still? Okay, let's go to this one. Page 78. The vertex of a parabola is 15, negative 30. The y-intercept is 0, 25. Is this enough information to write the equation? If so, do such. If not, explain. Well, if they give us the vertex, what form do you think we maybe should use to start with? Let's try vertex form, right? Vertex form says y equals x minus h quantity squared plus k. So when they gave me the vertex, what is this vertex? I mean, it's x and y, but really it is what? Is this the parent graph? No. So my x and y here from your transitioned or transformed parabola is your h and your k values. Because once you have moved your parabola from the parent graph, the new graph, the new vertex is at hk. So rewriting this means y equals, ooh, did I forget the a in front? Yes, I did. A times quantity, x minus h. So that's minus 15 squared plus k. K is negative 30, so you can just say minus 30. All right, so we've got that much. My y-intercept is 0, 25. Is that helpful to me in any way? If it's a y-intercept, is it on the parabola? Yes. So is this not another value of x and y? Yes. So can I substitute those in? Yes. So substitute 0 in for x and 25 in for y. And let's say 25 equals a times 0 minus 15, that quantity squared, minus 30. 25 equals a times negative 15 squared minus 30. 25 equals a, what is negative 15 squared? 225 minus 30. All right, I'm just going to turn this around. 225a minus 30. I'm solving for a, so add 30, add 30. Don't you love just to do some good old algebra sometimes? Was that a no? Or a yes? I do. I know it's crazy, but... solving for a, divide by 225, divide by 225. A equals, I can divide both of those and simplify by 5 over 5. That gives me 11 over, 45? Is that right? Check my math, 25, yes, I think that's right. So now that I know A is 11/45, I can rewrite this as y equals 11/45 times the quantity x minus 15 quantity squared minus 30. So essentially, we really just need to be solving for A. So if I have 11/45 as my A value, What does that tell me, if anything, for a parabola? What does that 11/45 tell me? If this is my A value, it means because it's positive, it is opening upward. It is opening upward. Okay? Any questions on this? Let's see what this next one is. Oh gosh, I don't like this one. I'm sorry, did I say that out loud? Two competing catapults launch pumpkins. Catapult A. Well, this is back on page 76. Catapult A launches from a starting height of 10 feet with an initial upward velocity of 45 feet per second. Catapult B launches from a starting height of 25 feet and an initial velocity of 40 feet per second. Which pumpkin, A or B, achieves a greater maximum height? Which pumpkin, A or B, is in the air longer? Is it possible from this scenario to determine the distance traveled horizontally? You. Okay. Somebody needs to tell me when it's 12 o'clock exactly. Okay, because we'll have to stop at 12. Okay, so initial height of 10 feet. So I think we need to use that formula, h of t equals, what was that? Negative 16 t squared. Negative 16 t squared plus initial velocity times t plus initial height. Okay, so catapult A, let's say A, launches from a starting height of 10 feet. So height is 10, initial velocity of 45. 45 times t, and this was negative 16 t squared plus. This is catapult A. Catapult B is h of t, negative 16 t squared plus, they have an upward velocity of 40 feet per second and a starting height of 25. Okay. We have to figure out maximum height. Well, gosh, looks like we need to do the old table. So at 0, we got time and height. At 0, we are at a height of 10. At 1, we are a height of 55 minus 16. What's 55 minus 16? Somebody tell me. 55 minus 16. 39. How about after 2 seconds? So 2 squared is 4. 4 times negative 16 is negative 64. So somebody add this. Negative 64 plus 90 plus 10. Or negative 64 plus 100. That would be 36. Is that right? Ooh, okay. So we're already coming down after 2 seconds. Let's take a look at catapult B. Time and height. At 0, We are at a height of 25. At 1 second, we are at, what's 65 minus 16? What is it? 49? Okay, so I think we already have our answer there, I would say. So which pumpkin achieves a greater maximum height? That would be pumpkin B. So max height is pumpkin B. All we did is substitute some values in. Which one is in the air longer? We might have to go further on the first one. So after 2 seconds here on pumpkin B, that would be 4, that is negative 64 plus 105. Negative 64 plus 105. What is it? 41. Somebody figure out what 3 is for pumpkin B. Somebody figure out what 3 is for pumpkin A. Three squared is 9. 9 times negative 16. I don't know. It's a big number. Who's got 3 for pumpkin A or pumpkin B? Sarah, you got one? Which one? Pumpkin A is what for 3? Just 1? Okay. And pumpkin B? Also 1. Really? Okay. So that means it's a height of 1. Which pumpkin is in the air longer? Jeez, I don't know. Is it helpful to go to 4 when we know they're going to both be negative? 4 squared is 16. 16 times 16, negative 256 plus 45 times 4. Somebody look up 4A for pumpkin A and 4 for pumpkin B. This will be the last one. Negative 66. How about pumpkin B? Negative 256 plus 160 plus 25? Negative 71. Well, based on the whole time seconds answers, which pumpkin A or B is in the air longer? You think? Why is it A? Can we tell? I mean, at 3 seconds in, they're both at a height of 1. I am not sure. I would say it's a draw. Or why are you thinking A, Lonnie? What? I can't hear you, but that's okay. All right, we got to stop anyway, so we will stop there.